Hello, this is Mr. Painter with another fabulous IXL tutorial. Today we're working on IXL CC.4. Find the number of solutions to a system of equations by graphing. All right, what we're going to do is we're going to do a quick recap of what a solution, no solution, and infinite solutions look like. All right, so a solution looks like when two lines cross at a single point. So we call that one solution. When two lines do not cross and they are something called parallel, like train tracks, that means we have no solution. And the reason why it's no solution is because the lines do not cross. Now, the last possibility is when you have a line that matches the same exact line, and we call that infinite. So when they're the same exact line, we call that infinite solutions. So now what we're going to do is we're going to take our two equations, the equation in the green and the equation in the purple, and determine, do they cross once? Do they not cross at all? Or are they the same line when you graph them? All right, let's give this one a try. We're going to start with the green equation here. We're going to start with positive 4. So positive 4 means go up 4. 1, 2, 3, 4. We're going to go ahead and click right there. So we're going to go ahead and put a point there. All right. Then now the slope 1 over 2 means to go up 1, rise over run. Remember our slope, rise over run. We're going to count up 1 and to the right 2. So from the 4, we're going to count up 1 and to the right 2. 1, 2 for our other point here. To create the line, you can just simply click on the graph. You notice this like cursor on your screen that will pop up, and you click wherever you want. Once you click the first point, the second point will be attached to it, and notice as you move, the line is ready to go. So what I'm going to do is I'm going to match it for the slope, and notice here I'm off by 1. So by deselecting it again, or just selecting it again, you can take it off and regraph it and fix it and make it perfect. All right, now to graph our second point, you're actually going to go down to the bottom here and select the purple graph, and notice now it is a little bit smaller of a box. That means it's ready to go for that. Well, how exactly do we do the purple equation? Well, we're going to do something called start with the y-intercept. The y-intercept is at -3, so we're going to count down to -3, -1, -2, -3. That lands right here. And the slope, what I'm going to do is I'm going to put the negative with the numerator. So which means I'm going to count down another 2, because instead of rising, the opposite, which is negative, means to fall instead of rise. So down another 2, down 1, down 2, and that positive 3 means to the right 3. 1, 2, and 3. So one more time on the slope. From the -3, we started right here, -3, -1, -2, -3. Go down 2 more, which is the numerator, down 1, down 2, and to the right 3. 1, 2, 3. And once you create your 2 points, by simply just selecting the points on the graph, you can go ahead and graph it. Now, if you notice, we have the 2 lines that are crossing at a single point. The single point that they're crossing is at -6, comma, -1, -2, -3, -4, -5. That's the -6, up 1. So the solution is -6, +1. Okay, now on this particular IXL, they're just asking for how many. Well, in this case, it's one solution because they only cross one time. So we're going to go ahead and select one solution. All right, we got ourselves another equation. Plenty more to go. Graphing is always good. Let's go ahead and clear the screen. All right, we're going to start with the green equation. Start with something called the y-intercept. The y-intercept always goes first. We're going to start at +4. So 1, 2, 3, 4. +4 lands right here. And our slope, negative, I'm going to put the numerator. So we're going to fall 2 and go to the right 5. So fall 2, down 1, down 2, right 5. 1, 2, 3, 4, 5. And there we go. There are our 2 points. So when our 2 points are selected, it will create a graph. Okay, next up we got our purple equation. So we're going to graph the y-intercept of our purple equation, which is positive 3. So we're going to count up 3. 1, 2, 3. Create a point. And the slope of down 1 over 5. Down 1 over 5. 1, 2, 3, 4, 5. And notice they are touching perfectly right there. Now, because both points are not on the exact same line, it's still going to be a one solution because they're only crossing one time at the point 5 and 1. So again, in order for it to be infinite solutions, they have to be the same line the whole way. But they're crossing one time again, so we're going to go ahead and just choose one solution. All right, smart score 26. He's doing fabulous right now. Green equation, start at positive 4 because that's the y-intercept. So positive 4, up 4. 1, 2, 3, and 4. That's a point. And we got fall over run. So down 1, right 6. Down 1, right 6. 1, 2, 3, 4, 5, 6. There we go. There is our green equation line. And click there. Click there. Beautiful job. Nice. All right. Purple. We have our y-intercept of negative 6. Negative 6 is where it crosses the y-axis. So go to negative 6, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6 lands right here. We're going to fall 1, right 6, down 1, right 6. 1, 2, 3, 4, 5, 6 lands right here. And those are our 2 points. And we're going to make the beautiful graph. There we go. All right. Take a look at the graphs. They're not crossing this time. And notice they are something called parallel. Parallel means they go up and down in the same direction. So they go up to the left with the slope of negative 6 over 6. So that gets me into my next part of the tutorial is when the slopes are the same, it either has to be a no solution or an infinite solution. It has to be one of those. But for sure, you will never have a one solution with the same slope. So you could say 50-50 choice right there once you have the same slope. However, in this case, because they're not the same exact line, we are going to go ahead and select no solution because no solution means they don't cross. The definition of a solution means two lines that cross. All right, they're not crossing, no solution. All right, green equation. We're going to start at the y-intercept of negative 6, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. All right. And we're going to go up 1 over 2. Up 1 to the right. 2, 1, 2. There we go. Notice they switched up my colors. So I'm actually doing the purple equation the whole time. So this is purple. There we go. All right, graphing the purple line. We're going to go ahead negative 6, up 1 over 2. Now the green one. So keep in mind that first one was the green line. They switched up my colors. That's okay because it makes it more fun to have different colors instead of green and purple. But now they just went purple green. All right, down 5, negative 1, negative 2, negative 3, negative 4, negative 5 lands right there. Up 1 over 2 lands right there. And to me, it looks like once again we have something called parallel lines. They are side by side and do not cross, so which means a no solution. So remember we talked before, same slope. It has to be no solution or infinite solutions. Now, in order for it to be infinite solutions, the y-intercepts have to be the same. So now we can actually do this without the graphing. I'm going to show you on the next tutorial, the next problem, how to do this without graphing. You still have the graph for IXL, but if you just want to know, like, okay, how can you tell by looking at the equation? You can't. Okay, turn this one in. We're at smart score 47, 4 question answered. Okay. What I'm going to do is I'm going to figure out the answer before even graphing it. I'm going to tell you how to do this. So to say, for an example, look at the slope first. We have a negative 3 over 4x and a negative x. Because the slopes are different, automatically when the slopes are different, it has to be a one solution. So one more time, if you see the slopes are different, automatically one solution. Just make sure you simplify the slopes to make sure they are different. But -3 over 4 and negative x are already simplified. So for sure, we're going to have a one solution. Now, let's graph it to see how I did on that and see if it's actually right. We got +1 for the green equation. So up 1 lands right there. And down 3, let's do fall over run. Down 3, right 4, down 1, down 2, down 3. Right 4, 1, 2, 3, and 4 lands right here. So that is going to give us our green equation. 1 there. Oh, 1 there. All right. Pink equation. Yeah, we got pink this time. +2, up 1, up 2, lands right there. And negative x for the slope is equal to -1 over 1x. So again, negative x equals -1 over 1x. So what we do is we go down 1 and to the right 1 on negative x. All right, so down 1, right 1 lands right there. And we're going to go ahead and select that. Now, it looks like a no solutions, but because the slopes are different, they're eventually going to cross, and they do at point +4 and -2. So check that out. I was right. I was right. No solution, or one solution, because they will cross based upon different slopes. Different slope, one solution every time. All right, turn that one in. All right, now on this one here, clear the board. Okay, take a look at this one here. Let's take a look at what the answer could be before graphing it once again. Based upon the slopes, -1 over 6 and 1 over 3, the slopes are different. Remember, we talked about when the slopes are different, we're going to have a one solution answer to this one. Slopes are different, one solution. All right. So now let's check and see if I'm right. Again, different slopes, always one solution because they're both simplified. Check and make sure they're simplified too. All right. Green equation. -3, which is our y-intercept, down 3, -1, -2, -3, and lands right there. And the slope, down 1, right 6, down 1, right 6, 1, 2, 3, 4, 5, 6, lands right here. All right. So green equation is there. Click there, click there. All right. Now we have our purple equation, except something's wrong with it. There is no y-intercept. Remember, the x is represented by slope, so we have y equals 1 over 3x. But because there is no intercept at all, that's +0. Now, if we're missing the number in front of the x, but the x is still there, we have 1x and it's 1. So sometimes students get mixed up. Well, how do you know when it's a 0 and how do you know when it's a 1? Again, completely missing, it's 0. But if the x is there without the number, well, x is the same thing as having a pencil, a piece of paper. Well, you had one pencil, so you put a 1. You had one piece of paper, so you put one paper. All right. Y-intercept is +0. So +0 means we're going to start at 0 for the y-intercept. Up 1 and to the right 3. So up 1 to the right 3. 1, 2, 3. Lands right there. And take a look at it. We're going to have our one solution because they have to cross. And we're going to select the purple equation. And remember to go back and forth. You click on them, so that's the green equation if you want to change the green. And if you want the purple equation, notice we go to the purple. And they are going to cross at one solution because they cross one times based upon different slopes. And I need to go ahead and actually select it first. So I want to go back. I'm glad that does that. I would have killed my score. It would have been very, very bad. All right. Take a look at this one. Again, without graphing it, how can you tell? We have the same slope, and we also have the same y-intercept. So what do we talk about when there's the same line twice? Look at same exact line twice. Simplify and everything. When the lines match exactly, it has to be an infinitely many solutions because the lines are right on top of each other. All right? Infinitely many solutions means the same line. So what I'm going to do is I'm going to graph the green line, and I'm just going to copy it for the purple line because it's the same thing all over again. So the green line, up 3, 1, 2, 3. That's the y-intercept. Y-intercept is the last number. Up 1 for the rise. To the right 6. Up 1 for the rise. To the right 6. 1, 2, 3, 4, 5, and 6 lands right here. So now we're going to go 3 and there. All right. Purple equation, we've already done it. It's the same exact thing as the purple equation. So y-intercept of 3, 1, 2. We got 1, 2, 3 lands right here. And up 1 over 6, up 1, right 6, 1, 2, 3, 4, 5, and 6. See how it's the same thing over again? So as long as you select the purple equation, you can graph a line right on top of it. And notice it's actually kind of cool. They show you both lines even though it's the same line. One doesn't bury the other. So there's your infinitely many solutions right there. And that's how you do it. All right, so my score of 66. Question's looking kind of funny. What we're going to do is we're going to fix it. Okay, let's fix the green one first. The green side, we have y equals negative. Okay, now the number is missing, but the x isn't. Because we have an x there by itself, an x by itself is 1x by itself. But because we have a 1x by itself, it is 1 over 1. Now, notice the y-intercept is missing. So the y-intercept is 0. So our left equation with the green is y equals negative 1 over 1 because negative x means there's 1x there the whole time. They just put the number there. Plus 0 because there's no y-intercept. Okay, now positive. Now the other one, that one's pink. We have y equals. Now notice there is no x value. No x value means 0 slope because there was an x there to begin with. And the y-intercept is the number by itself is positive 1. So the y-intercept was there, the positive 1, but the slope wasn't. So now we got our two equations ready to go. And now we can take a look at it. Now, what's the solutions before we even graph it? Based upon having negative 1 over 1 and 0x, because they are different, this particular answer has to be a one solution. Different slopes, automatically one solution. All right, so what we're going to do is we're going to graph it. Start at 0. Down 1, right 1 will be our green line. So we got y-intercept is 0, down 1, right 1. Purple. No, it's pink. I keep thinking that's purple. It looks like purple, but it's pink. Okay, now pink line. Start at positive 1, lands right there. Ooh, no slope. What does a no slope look like? A no slope is a flat line like the floor, the table, or the ceiling. It's a flat horizontal line. All right, so I'm going to select my pink line here, which means you can click here, you can click here, you can click here, 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 or you can click anywhere left, here, here, here. I'll just click right there. As long as a 0 slope, you make a flat line, that's all you got to do. So there you go. They cross at positive 1 and actually cross at negative 1, positive 1. One solution. We were right by looking at it. All right, almost there. Next up, we got these fabulous equations. We got a blue equation. Now, the blue equation looks kind of funny. It's not in y equals form. So check out how I do the blue equation. We have x plus y equals 1. Now, in order to get a y-intercept, we can ignore the x. So, bleh. Oh, what does that say? Y equals 1, which means we're going to put 1 point at y equals 1. Click, right? That's literally y equals 1. Now, one more time, we're going to write down the equation. X plus y equals 1. But now we want the x value. Bleh. What does it say? X equals 1. Literally, where it says X, find the 1, which is right here, and put a point. And there you go. That's how you do it when there's not in order. All right. X equals 1. Now, the orange equation is already in order. So, orange equation, leave it. And this is graph it. Positive 1, up 1, lands right here. And I'm just going to go ahead and click on it. You guys know how to do that one by now. Negative X is down 1 to the right 1, down 1 to the right 1. Oh! We got ourselves an infinitely many solutions. So notice the equations are different, but when you simplify it and work them out, they do work out to be the same equation. So that one's pretty sneaky. I liked it though. And if you need help on the X plus Y again, rewind the video a little bit, take a look at the tutorial right here. So again, you just solve for X and you solve for Y independently, which means by themselves twice, to get 2 points. Pretty nice. All right, next up we got -2. I was going to graph it. -2. Down 3, 1, 2, 3. To the right, 2, 1, 2. Blue equation is pretty easy. I don't like the orange equation because there's no slope. So we have y equals 0 slope because look, there's no x value. And the y-intercept is positive 4. So we got, let's see, positive 4. I'm going to select that. 1, 2, 3, and 4. Click there. And because there is no slope, just make a flat line. So again, you click anywhere to the right, or you click anywhere to the left, including on top at the intersection of the blue line. You click there as well. And because they cross one time, that is a one solution. Turn that baby in. And we're down to our last question. Clear the board. Now notice the last one is going to give us a challenge, but it's still not that bad. So we're going to solve it twice. We got 3x minus y equals 3. We're going to solve for x first. Yeah. You don't care about the y. So what this says is 3 times what equals 3. And because 3 times 1 makes the equation true, make the x value of 1 your first point on the x-axis. So x-axis is right here. Find the 1, which is right here. And that's going to be the first point. Now we're going to solve it one more time because I need a y value. So once again, we have 3x minus y equals positive 3. This time I don't care about the x, I care about the y. So, bleh. All right. So negative what equals 3? What if I do negative, opposite again, negative 3 equals 3? So again, you're trying to find the y value that makes the equation true. Because when you have a negative and a negative, you get a positive. But remember, I chose negative 3. So negative 3 is actually the answer I'm using because that's what makes the equation true. And it does work. So on the y-axis, you find a negative 3, which lands right there. And there you go. There's your 2 points. So 2 points here, here. And wait a minute. I think I just got myself a freebie. They are the same exact equation. 3x minus y equals 3, which means it's going to be infinitely many solutions because they're the same equation. But I believe you get this wrong if you don't graph the lines. So graph the green equation right there. Again, they match. And voila, this completes your fabulous IXL tutorial for CC4. Find the number of solutions to a system of equations by graphing. All right, have a fantastic day and take care.